second coordinate plus third coordinate, so that is alpha x1 minus alpha x2 plus alpha x3, 2 alpha x2 minus alpha x3, and 2 alpha x1 plus 3 alpha x3. So alpha will be outside, so x1 minus x2 plus x3, 2 x2 minus x3, and 2 x1 plus 3 x2. So alpha into t of x. From 1 and 2, t is a linear transformation. Now we want to find t is 1 1. To find t is 1 1, what should we do? If t of x is equal to t of y for any x and y, to prove x is equal to y. So let's start from t of x is equal to t of y. So that is equal to, using the definition, x1 minus x2 plus x3, 2x2 minus x3, 2x1 plus 3x2, that is equal to y1 minus y2 plus y3, 2y2 minus y3, 2y1 plus 3y2, that is equal to x1 is equal to y1, x2 is equal to y2, x3 is equal to y3. So that's why x is equal to y, and hence t is 1 1. Question 7a, second part. Let T1 from R2 to R3, T2 from R3 to R3, and T3 from R3 to R2 be the linear transformation given by T1 xy is equal to minus 2y 3x x minus 2y, T2 xyz is equal to y zx, T3 xyz is equal to x plus z y minus z. Find the domain and codomain of T3, T2, T1, and find T3, T2, T1 of xy. Also find T3, T2, T1 composition of 3 transformation of 1 1. Now T1 from T1, T2 and T3. So T3, T2, T1, that composition of 3 transformation is defined from R2 to R2 because of domain from T1 to codomain from of T2, T3. So what is domain of T1? That is R2, and codomain of T3, that is also R2. So that defined from R2 to R2. Now next T2 T1 of xy, that is T2 of T1 xy. So T2 of T1 xy, that is minus 2y 3x of x minus 2y. On that on that vector operate T2. How we operate T2? T2 is y zx, so that will become 3x minus x minus 2y and minus 2y. T3 T2 T1 of xy, that is equal to T3 of T2 T1 xy, 3x x minus 2y minus 2y, 3x minus 2y, x minus 2y plus 2y, so that will become 3x minus 2y and x. So T3 T2 of T1 of 1 1, that is equal to 3 minus 2 and then 1, so 1 1. Next question, question number 7b, first part. Express the following quadratic form in matrix notations. First is 2x square plus 5y square minus 6z square minus 2xy minus yz plus 8zx. So now you can see first equation is 2x square plus 5y square minus 6z square. So coefficient of x square, y square and z square become the main diagonal elements in the matrix. So 2, 5 minus 6, that will become the main principal diagonal elements, 2, 5 minus 6. Now the coefficient of xy is minus 2. So the entries of a12 and a21, that will be divided by minus 2 with 2. So minus 2 divided by 2, that is minus 1. So minus 1 and minus 1 in that both places. Minus 1, you can see on the screen. Now coefficient of yz, that is minus 1. Okay, so divided by minus 1 by 2, so that is minus 1 by 2. So the minus 1 by 2 are in that place. You can see on the screen that a23 and a32 in the place of a23 and a32 in the matrix. Okay, that means in second row and third column, and in third column and second row. Okay, second row and third column, and second column and third row. So a23 and a in place of a23 and a32, and the coefficient of zx is 8. So divided by 8 by 2, that is 4 4. So that in place of a13 and a31. So that means in place of first row third column and third column first row. Okay, first row third column, first row third column and third row first column, in third row and first column. So that will, you can see on the screen, that 4 4. Okay, so here is the matrix notation. XYZ matrix is 2 minus 1 4 minus 1 5 minus 1 by 2 4 minus 1 by 2 minus 6 into XYZ. Similarly, you can define the 2x square plus 3y square plus 6xy, that is a 2 cross 2 matrix. In the main diagonal 2 and 3, and the another diagonal we have 3 3, 6 divided by 2, that is 3 3. So 2 3 3 3. And the final question, question 7b, find the orthogonal projection of u equal to 1 2 3 4 along v 1 minus 3 4 minus 2 in R4 with respect to the Euclidean inner product. So projection of u on v, that is defined as inner product uv upon norm v square into v. So inner product uv is equal to 1 2 3 4 1 minus 3 4 minus 2, that is equal to 1 minus 6 plus 12 minus 8, that is equal to minus 1, and norm v square is equal to 1 plus 9 plus 16 plus 4, that is equal to 30. So put all these values in the equation. So projection of u along v that is equal to minus 1 upon 30. Okay, because inner product uv is minus 1 and norm v square is 30. So minus 1 upon 30 into v, so that is 1 minus 3 4 minus 2. So minus 1 by 30, 1 by 10, minus 2 by 15, 1 by 15. So here we complete the solution, the whole solution of GTU question paper December 2011. So goodbye, have a nice day.